Hello and a very good evening to one and all. This is your GradSquare mentor, Chris Dana here, and I'll be taking you through the topic base system today. Now, base system is one such topic that now and again I've been hearing from the students. It's the type of question that are coming from this particular topic are very difficult to handle. Okay, so that is why I came up with this video just to prove that base system is actually a very easy topic. Okay, base system is something that you use in your day-to-day life. Okay, right, basic additions, basic multiplication, everything in your daily life, the calculation that you use are done in the decimal base. So base system, you are using it daily, so it becomes very easy for you to relate to the real life matter and then study things, right? So and in this particular session also, okay, I have thought of giving you the concepts, and also I have thought of putting in a few questions from the CAT paper or from the non-CAT papers which have been previously asked, so that what we study and what is expected of us, okay, do not become a mismatch. They have to be in sync with each other. And I have specially taken questions from the previous year papers mostly. Okay, and one more thing here is this particular topic base system can be either in the quant section or it can also come in the LRDA section. If it comes in the quant section, there'll be only a single question maximum. Okay, and if it comes in the LRDA section, then there's going to be a complete set based on this. I agree that this is going to be a rarely asked topic, but again, if you look into the history, okay, at least every 2 years there are questions. Okay, at least in the whole season of MBA, every year there's one question on base system, right? So it is important that you know, and this is, since it's a very easy topic, 3 marks is very easy to put into your pockets. That is why, and this topic, if you study for one day, okay, after that you can just close your books and throw this away. Okay, you'll remember it throughout your life. That is a major advantage of this topic. So one day you spend to study this topic, 3 marks into your pockets. Okay, and if at all it comes in the paper, you will not be baffled by looking at the question paper. You will be able to easily tackle it out. Right. So let's get into this topic. And before getting into this topic, I would like to tell you is I'm there on the live chat. So if you have any kind of a doubt, please do put it there. I'll be happily responding to your doubts. Right. So first of all, let's get into what is base system. Okay. So first of all, whenever you are getting into basis, okay, the day-to-day calculations that you do, I think you know we are doing the day-to-day calculations in your decimals, right? And decimals base is going to be 10, right? So what about this whole thing, base system? Why do we need base system and all? Just have a look. See, we humans are using the decimal system, base 10. Okay, but when you're talking to a computer, if you ask its IP address or whatever, it is obviously going to respond in terms of binary, because the computer knows only how to respond and understand things in binary, right? But how do you communicate? Okay, obviously we do not understand binary, okay, until it's a complex process of conversion. Okay, so what we use a middleman who is called the compiler or the interpreter, who interprets or translates things for us and gives it into the language binary format that we can understand. Correct. So this process of conversion is actually a easy one only, which can be done in a fraction of seconds by the computer. So for us, it's just going to take at least 30 seconds for this conversion, right? So for the time reduction, we are using the compiler. But when it comes to the questions, okay, we need to know the basic conversions as well. So what we'll be looking into this particular session is the basic conversions between all the bases. We'll also look at how to do the operations in different base system, like decimal base system operations, addition, subtraction, all we are comfortable with, but how to do it in the different base systems, that we'll be learning it. Then after that, we will look into a few questions as to what kind of questions we can expect in the exam paper. So this is not going to be a very long video, my dear. We'll just take around 20 to 25 odd minutes of your time, and then try to get a master or get mastery over this particular topic, right? Okay, so now getting into the basics of base system. Base system is nothing but basic counting. Okay, now I think all of us can relate to decimal system. So what I'm going to do is, first of all, we know that the different bases that we are using is decimal, that is from 0 to 9. Okay, the other base that you can use is going to be binary, which is going to be using only zeros and ones. Base is going to be 2 here. Correct. Next you have octal, which is from 0 to 7. Okay, base 8 here. And then you have hexadecimal, which is the next important one. So here you can use from 0 to 15. Okay, but 0 to 15, the problem is now only the first 10 digits, that means 0 to 9, you will be representing it in terms of numerical format. The remaining you will put it as A, B, C, D, E, F. This refers to 10, 11, 12, 13, 14 and 15. Now, why do we do this? We do this because, say for example, you have a number like this in base 16. Okay, so this is 10456, or is it 10456? Now there arises a confusion, correct? So in order to avoid a confusion whether this is 10 or this is 10, so 10 will be represented as a 10 itself, but 10 will be represented as A. Confusion avoided there, right? This is the major thing. Now, how does this basic counting work? First of all, let us have a look at it in decimal, because decimal is something that we all know, right? Now, first of all, decimal uses 0 to 9. Any base, if you have a base of n, any base n will use the digits from 0 to n minus 1. So decimal which is in base 10 will use the digits from 0 to 9. That's it. Understood? Now, let's have a look at this. So decimals, let's have the counting first of all. First, 0 can be used. Second, 1 can be used. 2 can be used. 3, 4, 5, 6, 7, 8, 9. Now, after 9, there are no digits that can be used in decimals. So, I just have to use a combination of the numbers that are available from 0 to 9. Okay, so which is the least number that is possible? Now I have to go for 2-digit numbers, right? So which is the least 2-digit number that is possible with a combination? It's nothing but 1 and 0. Correct. Or I can also say that this 9, okay, automatically becomes 0. The counter is going to repeat itself. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Again 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But what happens is when this counter becomes 0, okay, then you'll have to add to this counter. It becomes 1. Right? So 1, 0. Now next one, if you see, will be nothing but here 1, and this stays as it. Here you'll get a 1 again. Okay, so this will be 11. The next one is obviously going to be 12, 13, 14, 15, 16, 17, 18, 19. And after 19, that 9 will become 0. And then in the tens place, one counter will get increased. That will become 20. Right? So this is the basic counter that is used in decimal. Now similarly, how do we use the same counter here in your binary? First of all, in binary, only zeros and ones can be used. Right? So first I wrote 0. Then I wrote 1. Now again, now it has to repeat 0, 1, 0, 1 has to repeat. So when it becomes 0, automatically the tens counter has to increase here. Okay, so that will become 1. Now I can use after 0, 1 there in the ones place, right? And the counter in the tens place remains the same. Now next one, 0, 1, 0, 1 done. So again 0 has to be there. The counter on the next digit will be increasing 1. So it will become 1 and 0 again, because I cannot use the 2 there. Okay, I can use only zeros and ones. So here 0, 1. Now next, when it's becoming 0 here, I know that this counter has to increase by 1 plus 1. Okay, now this becomes again 1, the counter stays. Now when this becomes 0, this counter has to again increase by 1. So when you increase by 1, 1 and 1 becomes 2. 2 cannot be used. So 2 generally is 1, 0. So put a 0 here and this counter increases by 1. That's how it goes ahead. Right? So now we'll just see how it works. Again, you'll have here 101, then you'll have 110, then you'll have 111. Okay, then you will have 1000 here, and then you will have 1001 and so on. Got it? So the corresponding decimal and binary numbers are here. 0, 0, 1 can be written as 1, 2 can be written as 10, 3 can be written as 11, 4 can be written as 100, 5 can be written as 101, 6 can be written as 110, 7 can be written as 111, and 8 can be written as 1000, and 9 will be 1001, 10 will be 100, 1010, 11 will be 1011, and so on. right? So this is how the counter goes on in binary. So for any kind of a base, the counter will go ahead this way only. Okay, right. Now, let us look into the basic conversions. First of all, when you have a number in decimal format, how do you write this number first of all? How do you generally write this number? We expand this number. We know that here this is the ones place, okay, and this place value here is going to be nothing but 1, correct, and this is going to be nothing but the tens place, correct, ones place, the tens place, and the hundreds place, correct. So what I do is 2 into 10 power 0, because this is in base 10, 7 into 10 power 1, and 5 into 10 square. Now whatever I have beyond the decimal part, okay, will be in the format 10 power minus 1, 10 power minus 2, and it keeps on going. So plus 1 into 10 power minus 1, 3 into 10 power minus 2. Okay, so when you expand this, you simply get here 5 into 10 square is 500, 7 into 10 is 70, 2 into 1 is going to be 2, 1 into 10 power minus 1. 10 power minus 1 is nothing but 1 divided by 10, which is 0.1. 0.1 into 1 is 1 here. This is now 1 divided by 100. So 1 divided by 100 is 0.01. 0.01 into 3 is going to be 0.03. So if you add this up, you finally land up with 572.13. Okay, so basic decimal number, we know how to expand it. Okay, now let's have a look at if the number is in another base. How do I convert into base 10? Now remember that you will use the same method, but in base 5, this will be in the format 5 power 1, 5 square, 5 cube. This will be 5 power minus 1, and this will be nothing but 5 to the power minus 2. That's all. We just need to know the place values, correct, and we can make use of the same thing here. Now let's have a look. What will I do? Now this will be nothing but 4 into, sorry, this is 5 power 0, this is going to be 5 power 1, and this is going to be 5 square, correct? So yeah, now here this is going to be 4 into 5 square, this is going to be here nothing but 3 into 5 power 1, okay, and 2 into 5 power 0. So done with the integral part. Now going on to the decimal part, this is now going to be 1 into 5 to the power minus 1 plus 3 into 5 to the power minus 2. 5 power minus 1 is 1 by 5, which is 0.2. Okay, and this is nothing but 1 by 25, 1 by 25 here. Okay, so let's have a look how the calculation goes on. So 4 into 25 becomes 100, 3 into 5 becomes 15, 2 here, 2 into 1 is 2. Now this is 0.2 here, correct. Now 3 into 1 divided by 5 square is 25. Now 1 by 25 is going to be how much? 1 by 5 is 0.2. So this divided by 5 is going to be 0.04. So 0.04 into 3 is going to be 0.12. Now you do the addition of this, you will end up with 117.23. So this is how you convert any number in any base, in base n. You convert any number in base n to your base 10. Okay, now if you go to various websites or other videos, they'll tell you as to how to convert a decimal into octal will be one format, okay, decimal into binary will be one format, then decimal into octal will be one format, decimal into hexadecimal will format. So they'll give you n different formats here, but I've just generalized it, and I'm just generalizing you into two types. One is conversion of any base to decimals, and the second one that we'll be seeing is decimal to any other base. These are the only two things that we are going to see. Okay, so I hope now you're clear with how to convert a number in any base n to base 10. Okay, so you just have to remember the place values and then go ahead with it. Now let's also have one more example here. Now this is in base 8. So this will be in the format 8 power 0. This will be 8 power 1, 8 square, and then 8 cube here. This will be 8 power minus 1. This will be 8 power minus 2. Correct? Now let's have the look at the calculations. Going over to this. Okay, 5 into 8 cube plus 0 into 8 square plus 3 into 8 power 1 and 1 into 8 power 0. Okay, and then going into the decimal part, 2 into 8 to the power minus 1, and then here I have 4 into 8 to the power minus 2. Now just finish off this calculation, you will land up with 2560 plus 0, because 0 into anything is 0, and then here 24, here 1. Okay, and then now this value, 2 into a to the power minus 1 is nothing but 2 into 1 by 8. So this gives you nothing but 1 by 4. 1 by 4 is 0.25. And here I land up with 4 into 8 to the power minus 2, which is nothing but 1 divided by 8 square. So I can write as 4 into 1 divided by 8 into 8. So this gives you nothing but 1 divided by 16. So if at all you are good with the basic percentages, fractions, and its multiplying factor, then you will know that 1 by 16 is nothing but 6.25 percentage, or it is 0.0625, and that I can directly take care. So whatever you study in the base definitely is going to be applied in whatever topic comes ahead as well, right? So the value for this, if you add up, will give you 2585.3125. Okay, so this is all about conversion from any base to decimals. Now let's go and have a look at conversion from decimal to any other base. So when I have a number which is in decimal, okay, I want to convert it into another base which is going to be octal. Now, first of all, note that in the exam now, so far you have never ever got decimals, but I'm teaching you decimals also, decimal in the base, this part, okay, not the decimal base. Decimals also, because if it all comes in the paper, you should be struggling with that question. So just to make you aware of it and keep you well informed, I'm just giving you this, okay. Others, the past year papers decimals we haven't got so far. Right. So 314.58 in the base 10, you want to convert it into base 8. Now, so far, what have you been doing? Base n. Okay, to base 10. You have been multiplying with the place value. So here, obviously, in the reverse case, you'll have to divide. And you will use a L division rule. Why? Because when you're using the octal system now, you can use the numbers only from 0 to 7. Okay, so when you divide by 8 and take out the remainder, you will get the possible values in 0 to 7. So what you do is you first take this integral part, 314. You do the L division by 8. So 8 will go here 3 times, 24. Okay, remainder is going to be 7. So in 74, it goes 9 times, 72, remainder is going to be 2 here. Again divide, you will keep on dividing till you can't further divide it. So it goes here 4 times, 32, remainder is going to be 7. Now you can't further divide 4 by 8. So now you write the number in this order. So the integral part here will be equivalent to 472. Now looking into the decimal part. The decimal part you take 0.58, and I'm going to look only into strictly two decimals here also, okay, in the other base also. So what I do is I take this 0.58 and multiply it into 8. Now I get here 4.64. I take the integral value and I keep it aside. Okay, now I take the decimal part and then I continue the multiplication with 8. I get 5.12. Now I write 5 and again I'll be taking this and then I'll be doing 0.12 into 8 and then doing it again and again. Okay, but I am worried only up to two significant places after the decimal, so I'll stop it here. Okay, so answer is going to be 472.45 here. This is it. So calculation is going to be very, very easy. Let's do one more. Okay, you just try it out. I'll give you a minute here. Please, you try this out, and then after that, we'll do the discussion. You have to convert a base 10 into binary. Please do this basic conversion. Take your time. Okay, so this basically was actually important and it was also easy because base 10 and binary is something which you use now and again. Okay, so now let's go ahead and look at this conversion. First of all, do the L division here, divide by 2. You get here 52 and a remainder of 1. Again divided 26 and a remainder of 0. Again divided by 2, you get 13 and a remainder of 0. Again divided by 2, you get 6 and a remainder of 1. Again divided by 2, you get a quotient of 3 and a remainder of 0. And then again by 2, you get 1 and 1 there. So now write the number in this order. You will get the value in base 2. That's all. Okay. So these are the equivalents, my dear, and it's actually very, very easy. Conversions are very, very easy. Okay. So now hope you understood how to convert a number from any base to decimal and also from decimal to any base. Okay. Right. Now we are getting into the basic operations after this. Okay, and before that, let's just have a look as to whether conversions can be done only that way or not. Say for example, in the exam I am asked to convert a number from base 5 to base 8. Then what is the process? I do not know how to convert from base 5 to base 8. All I know is conversion of any base to decimals, and I know how to convert a decimal to any other base. Correct. So you will go via intermediate step of converting this number into base 10 and then going ahead. So one extra step there, nothing else. Okay, and there are a few tricks that you can remember here as well. Okay, now when you're specially converting a number in base 2 to base 4, remember that this is nothing but 2 square. Okay, or you are converting a number in base 2 to base 8, which is 2 cube, or if you're converting it into hexadecimal, which is 2 power 4. Okay, so you can use a few shortcuts. And is it only from binary to any other number which is in the format 2 powers? No, you can use it also for numbers like you have base 3 here, and this is nothing but 3 square. So the same process you can use it. Now how to do it? Now base 2 to base 2 square. 2 square, so group it in terms of 2 digits. 2 digits from the right hand side. Okay, from the decimals you'll start grouping it. So 2 digits. Now write down the equivalence. 0 can be written as 0. Correct. 10 is nothing but 2. 0 again is going to be a 0 here. 1 is going to be 1. 1 is going to be 3. And again 1 is going to be 3 here. Right? Understood this or not? 331020. Now, if you ask me again here, how do I do this conversion? Remember, we had learned the equivalence of decimals and the binary values right in the first slide. Okay, 0 was 0, 1 was 1, 2 was 10, 3 was 11. So the same thing I've used it here. So 4 will be 100, 5 will be 101, 6 will be 110, 7 will be 111, 8 will be 1000, and so on. Okay, now you can also keep in mind that 2 will be represented as 10 in binary, 4 will be represented as 100, 8 will be represented as 1000. So these values you can keep it in your mind. Okay, now going over with from base 2 to base 2 cube. So 2 cubes, so group it in terms of 3 digits. So again here 0, here this is 001, which is 1, 101. So 101 just comes right after 4, no? So 5, which is nothing but 101. And 111 will be just before 8, that is 7, 111. Okay, so this is going to be 7510. Okay, now conversion into base 2 power 4. 2 power 4 again group it in terms of 4 digits. So basic equivalent of 1000 is going to be nothing but 8 here. Okay, 0100 is nothing but 4 here. Okay, and 1111 is obviously 9 is going to be 1001, 10 is going to be 1010, 11 will be 1011, 12 will be here 1100, 13 here is going to be nothing but 1101, and I can say that 14 here will be 1110, and 15 is going to be 1111. So 15 is going to be the last digit in the hexadecimal format. So after 9, how do I put it? A, B, C, D, E, and F. So this is going to be F, 4, and 8 here. Right? Now, how do I use the same thing here in base 3 to base 9? Again, base 9 is 3 square, so I group it in terms of 2 digits. For your easy work, I'm just listing out the numbers also. In base 3, I can write 0, 1, and 2. After that, I cannot use 3. So the next one, what happens? 0, 1, 2, the counter now becomes again 0, 1, and 2. So here, this counter has increased by 1. So 1, 0, 1, 1, and 1, 2. Next, again, after 0, 1, 2 here, I have to use again 0, 1, 2. Then this next counter will increase by 1, that will become 2, 2, 2. So 20, 21, and 22. Okay, so this will be 1. Okay, let me use another color here so that I can represent it easier for you. So 0 will be represented here with 0. This will be 1, 2, 3, 4, 5, 6, 7, and 8 here. Okay, now this is 1, 2. 1, 2 is nothing but 8. Correct. 2, 1 is nothing but 7. Sorry, this was not 8, this was 5. Sorry, this was 5. Okay, and then here 2, 1 is nothing but 7. And simply a 2 here. 2, I can write it as a 2 itself. That's all. So this is going to be 275 here. Okay, so hope you are now clear with this. So these are some tricks that you can use, okay, especially for converting from base n to base n square or n cube or n power 4 or n power 5 and so on, right? Now, a basic calculations here, the basic calculations. First of all, let's have a look at this. When I have a number 8358 in base 10 plus 5684 in base 10, this simple addition, how does it work out? First, I write it as 8358 and then 5684. Now, I proceed from here. Now, 8 plus 4 is 12. So, I can't write 12 directly. I divide it by 10 because it's a base 10. I look out for the remainder. The remainder is going to be 2. Okay, and 1 goes as a carry this side. Now 8 plus 5 is going to be 13. 13 plus 4 is going to be 1 is going to be 14. I can't write 14 directly. I divided by 10. The remainder is going to be 4. So 4 I put it here, and then the counter increases by 1 this side. So here 6 plus 1 is 7. 7 plus 3 is going to be 10. So 10 by 10. Okay, the remainder is going to be 0. I put it here 0. The counter just increases by a 1 here. 9 plus 5 is going to be nothing but how much? 9 plus 5 is 14. So 14 again I divide by 10. The quotient is 1. So that goes as a counter this side. Counter increment by 1. And then the remainder is 4. So that comes out here. So 1 as it is, it comes here. So 14042 has to be the number. That is the addition of these two. So same kind we will apply for this as well. So if I have 3542 and this is 4124. Okay, now what I do, this is in base 6. Okay, now I take 2 plus 4, 6. Okay, 6 I can't write it as it is. I take 6. Okay, I divide it by 6. For 6 now I can write only the digits from 0 to 5, my dear. So anything above it I'll have to convert. Okay, then and then. So 6 by 6, the quotient is going to be 1 and the remainder is going to be 0. So I put a 0 here and then the counter increases here by 1. So this is 5 plus 2, 7. 7 is greater than 5, so I can't write it. So divide, convert it. So quotient is again going to be 1 and the remainder here is going to be 1. So I put a 1 here and this counter increases by 1. Now this is again going to be 1 plus 5 is 6. 6 plus 1 is 7. So 7 again conversion, 1 is a remainder and this counter, the quotient increases by 1. So 4 plus 4 is 8. Now 8 again I have to convert. 8 divided by 6, quotient is going to be 1 and the remainder is going to be 2. So a 2 here and this counter increases by 1. So 1, 2, 1, 1, 0. This becomes its equivalent in the basics. Okay, so addition, subtraction, multiplication, everything, my dear, whenever you're writing each digit, okay, just check. If it's in base n, it should contain only from 0 to n minus 1. If it is from 0 to n minus 1, write the digit as it is. But if it is greater than that, you just do the conversion then and there and then finish it off. That's all. Okay. Now, here subtraction. Going to subtraction in base 10. When I have 237 minus 199. How do I do this? First of all, 7 and 9 I cannot directly subtract. So I have to borrow. This is base 10. So I reduce this by 1 and I borrow a 10. This becomes 17. So this is base 10. So I can borrow 10. So 17 minus 9 is going to be nothing but 8 here. Right. Now 2 minus 9 is not possible. So reduce it by 1 and then here borrow a 10. So 12 minus 9 is going to be 3. So this is 0. So 38 is the difference in base 10. Similarly, in base 5, what do I do? 422 minus 243. Now this is in base 5. So the maximum that I can borrow is going to be 5. Now 2 minus 3 is not possible. So I reduce this by 1. And now I borrow. How much can I borrow? I can borrow only a 5 in this particular case. Correct. So now that I have borrowed a 5 here, this becomes 5 plus 2, which is 7. 7 minus 3 is nothing but 4, which is from 0 to n minus 1. I can use here only from 0 to 4, since this is base 5. So no conversion required here. Now 1 minus 4 is not possible, so reduce this and borrow a 5 here. This becomes 6. 6 minus 4 is going to be 2 here. Okay, so this was 3 now. So 3 minus 2, 1 comes here. 124 was the difference in base 5. Correct. Now going on to this particular question, my dear. From now on, we are going to look into the different types of questions. Now just 4 more questions left out. So I want you to sit down and try these questions. I'll give you 2 minutes for each question. Please do it. And please comment your answers on the chat box. Okay, I think this was the easy one. Now we can do the conversion. Convert the number 1982 from base 10 to base 12. So remember, base 10 to base 12, we have to go with the division rule, right? So divide by 12. Now 12 goes here 1 times, 12, remainder is going to be 7. In 78, 12 will go exactly 6 times. 72, remainder is going to be 6. So 12 goes 5 times, now remainder is 2. Again take and divide it by 12. 12 goes here 1 times, remainder is going to be 4. So now again it goes 3 times, 36. Remainder is going to be I think, yeah, 6 now. Yeah, remainder is now going to be 45. Yeah, remainder is going to be 9. So now this side, I again take it by 12. Okay, now goes 1 times, remainder is 1. So write the number in this format, 1192. It was option 3, right? This was pretty easy, right? Now please take 2 minutes for this. Now this question, typically, why? Because if anything is in base 10 to base n conversions and all, we might be very comfortable with it. And doing anything in base 10 also, we might be very comfortable. Now this is in base 9. So I just wanted to check this out. 2 minutes. How many 4-digit numbers in base 9 are perfect squares? Okay, so for any number that is given in a different base, you people are comfortable with base 10, right? So try to relate it with base 10. Okay, now how many 4-digit numbers in base 9 are perfect square? Now before this, okay, let me give you a small example. Let me take an example of base 5 and base 10. Okay, now can you tell me, in base 10, if I have a number 5, how can I write that same number in base 5? I have to convert it now. 5, I have to divide it by 5, I get 1 and a remainder of 0. So the number is 10 here. If I have 25, how can I write that number? 25, I have to convert it. So goes 5 times 0, again goes 5 times 1 and 0. So this is 100. So can I say that 125 in base 10 can be written as 1,000 in base 5, correct? This is 5 power 1, this is 5 square, this is 5 cube. Now base 9, okay, we are talking about 4 digit numbers. The least 4 digit number will be 1,000, right, in base 9. And its equivalent in base 10. What would be the equivalent in base 10? See, in base 10, if it is 5 power 1, that is 10. This is 5 square, this is going to be 100. So here I can say, here, if it's 5 cube, then it's going to be 1000. So can I say that this is going to be nothing but 9 cube in base 10, which is nothing but 729. Okay, now I can say that the next one that I can easily figure out, this is going to be 9 to the power 4. Correct? I think this we can easily figure out using this pattern. Not only here, my dear, use base 2 and use base 10. Okay, in base 10, 2 power 1 can be written as 10. 2 square can be written as 4, which is nothing but 100. 2 cube can be written as 1,000,000. Okay, I think we have seen this, so it's much more relatable. So the same way here, 9 cube, the least 4 digit number here is going to be 100. And then the first 5 digit number is going to be 10000. Correct? So I can say that the 4 digit numbers, okay, we are looking only for the squares. So can I write 729 in terms of a square? Can I write it in terms of a square? This is 27 square, correct? And this is nothing but 81 square. So the 4 digit numbers in base 9 that are perfect squares obviously should be greater than or equal to 27 square. Okay, because 27 squared, this 1000 is equivalent, 1000 is going to be the least 4 digit number, so I have to include this. So 27 squared included, but it definitely has to be less than 81 square. It cannot be 81 square because 81 square becomes a 5 digit number. So the number below this was a 4 digit number, so it has to be below that. So I can see that only from 27 square up to 80 square can be counted. So how many terms are here that you have to figure out? How many terms will be here? From 1 square up to 26 square, there are 26 terms. And from here to here, there are 80 terms. So from here to here, there will be 80 minus 26, which is going to be 54 terms. Answer was option B for this. Right? Okay. Now, going on to the next question. Okay, this question has variables along with base system. Okay, but try to understand the question, my dear. It's going to be pretty easy for you. Do it. 2 minutes for this again. This question should be pretty easy. 30 seconds more. Okay, so let's start with the discussion of this topic here. See, first of all, let A, B, and C be distinct digits. Okay, consider a two-digit number AB and a three-digit number, two-digit number AB and a three-digit number CCB. Both defined under the usual decimal system. So decimal system, so this has to be pretty easy for us. And the only condition is AB square is equal to CCB. And CCB is going to be greater than 300. Okay, note that the square of a number, a 3 is a three-digit number, square of a two-digit number. So two-digit number whose square is going to give a three-digit number. I think start from 10 square, correct? So 10 square becomes 100. This is the first one. Okay, so this keeps on going up to 31 square, right? Because 32 square is definitely going to be greater than 1000. So we can proceed only up to your 31 square. Now let's have a look as to what I can do in this first of all. Now 31 square is also going to be 961. Let's write it out. Now what is the value of B? First of all, AB square is going to give you CCB. First clue is that whatever is coming in the units place is coming here as it is. So when you square a number, the unit digit has to come out as it is. So for 10 it is possible, but again this is greater than 300. So 11 square is less than 300, 12 square is less than 300, 13 square is less, 14 square is less, 15 square is less, 16 square is also less, 17 square is also less. So I can go only from 18 square and check. I can check only from 18 square, right? Below that, all the numbers are going to be less than 300. So 18 square is the first number which is greater than 300. So from 18 square, I have to check only up to 31 square. Now the thing is, the unit digit is coming as it is. So if you have a unit digit of 8 here, 8 square will give you 4, right? Now if you have 9 square, that will give you 1. So 8 is not possible, 9 is not possible in the units place. Okay, now 0 is possible. Okay, so 0 is possible, so I can take 20 and 20 square, or I can take 30 square as well. Okay, now 1. If I have any number with a unit digit of 1, in the square also unit digit becomes 1 only. So I can take 31, I can take 21 within this range. Okay, now if I have 2, 2 square will be 4, I can't take, 3 square will be 9, I can't take, 4 square will be 6, I can't take it, 5 square will be ending with 5. So I can take that also. So 25 square comes here within that range. Okay, I can also take a 6, correct? Now if I take a 6, any number ending with 6, its square will also end with a 6. So the number in this range is going to be 26 square. Now one more thing is, the number has to be in the form of CCB. CCB means these two digits have to be repeated. So this is going to be 20 square is 400, which actually doesn't match this pattern. Okay, 30 square is also 900, which will not match the pattern. Now 31 is 961. These two have to be the same. This is also not matching. 21 square, what is 21 square? 441. So this is matching CCB. AB square is equal to CCB, matching it. Okay. Next 25 square is going to be 625. It doesn't match. 26 square also doesn't match. So there was only one number that matched it. So and that was AB's value was 21. This was 441. What is the value of B? The value of B is going to be 1. That's it. Okay. Now one more question for you. Please try out this question, my dear. 2 minutes. 30 seconds more. Okay, this was actually a very easy one, my dear. Okay, in a number system, the product of 44 and 11, okay, is going to be 1034. The number 3111 in the same base system, when converted to decimal, becomes what? So first of all, the main thing is I have to figure out what base this is. Correct? So to get what base it is, okay, I can do two methods. One is applying the crisscross method and doing it manually first of all. So when I'm doing this manually, I know that, see, multiplication 44 and 11 here, okay, 1 into 4 will give you a 4 here. Okay, so 4 is coming as it is. That means the base definitely has to be greater than 4. The base cannot be 4. Okay, the base has to be greater than 4. It can be 5, 6, 7, 8, 9, whatever it is. Okay, next crisscross. 4 plus 4 has to be 8. But instead of a 8 here, you are getting a 3. So the conversion has happened. 8 has been divided by that base and the remainder has come out to be 3. Correct? So if I divide the number by the base n and the remainder is 3, what is the possible value for n? N can be nothing but 5. So this number is in base 5. So this number 3111 is in base 5. You just have to convert that number into base 10. How do you do the basic conversion? Okay, you have to look into the place values. This is 5 power 0, this is 5 power 1, this is going to be 5 square and this is going to be 5 cube. So you will get here 3 into 5 cube plus 1 into 5 square plus 1 into 5 power 1 plus 1 into 5 power 0. This is going to give you 1 plus 5 plus 25 plus 5 cube is 125. 125 into 3 is going to be 375. So 400 plus 6 is 406. You get option 1. Okay. Now you could have done it this way, or you could have also framed the equation. Now how do you frame that equation? Move ahead. First of all, you have the number 44. This is in base n. So this place value would be n power 0. This one would be n power 1. So I can write it as 4n plus 4. Okay. Product with 11. 11 is nothing but, again, base here is going to be n. So n power 0 and n power 1. I can write as 1 into n is going to be n plus 1 into n power 0 is going to be 1. So product is nothing but 1024. Here also n power 0, n power 1, n square and n cube. So you get here 1 into n cube plus 0 into n square is 0 plus 3 into n plus 4 into n power 0. Now you get this equation. You have to simplify it. Now the only thing is you will be getting a complex equation here. Okay, when you multiply, you will get n cube minus 4n square minus 5n is equal to equation. This equation will be there. After that, you have to factorize this equation. Okay, so if you factorize, you take n this side, n minus 5 into n minus 1 is equal to 0. So you will land up with either n. Okay, I'm just helping out how to do, my dear, but I do not advise this at all. I do not advise it at all. Okay, because there are interior calculations. Okay, too much of calculations are there. Factorizing is not easy for everyone. Okay, so n either can be 0 or n minus 5 could be 0 or n minus 1 could be 0. So here n will be 1. Base can never be 1. That means I can use only 0. That's not possible. So n could be 5. N cannot be 0. Okay, so the base 5 you can figure out this way also. But again, this is not advisable, my dear, because you know how to do the crisscross method. It's very easy. Okay, and figuring out the base through that makes much more sense. Okay, so we have seen basic conversions here. We have seen questions related to using too many variables or using operations in another base, and also using decimal system. Okay, so I think this gives you a complete rough draft about how the questions are expected in the paper. Also do practice similar kind of questions, okay, at least 20 to 30 on a day, and then wind it up. Right. So thank you everyone for being active till the end. Thank you.